Hey guys, welcome back to the channel. It's so nice for you to be here. We are Group 1 and in today's video, we are going to do a commentary and reaction video about K Nearest Neighbor. Don't get your hopes up because you won't find this on any streaming platform. Though I'll have to spoil you. The climax is spectacular. Anyways, where was I? Oh yeah, before we start, let me give you a quick rundown on the members of Group 1. We have Timothy Canonoy, Bernice Chua, Cristina de los Santos, Justin de los Santos, Petrine Ann Fernandez, Carlo Riodica, Austin Tan, and I'm Luis Alaya Remiscal. Getting all that out of the way, let's hop straight to the video.
Shout out to Sir Deliosa for giving us a brief outline on what we're going to tackle today. So, for the first part, we have the overview, the definition of K nearest neighbor, kind of analytics, and relationship to predictive analytics. Next is the history, including its origin. Third, its uses, where can it be used in some examples, and lastly, how it works in demonstration. So to begin our discussion, let us first ask what is K-nearest neighbor? Well, for beginners, it is an approach to data classification that estimates how likely a data point is to be a member of one group or the other, depending on what group the data points nearest to it are in. In simple terms, it is an algorithm that predicts the user's preferences or most probable choices based on similar characteristics from the user's data taken from their behavior and history.
So, what kind of analytics is K-nearest neighbor? It is a part of supervising learning, more specifically predictive analytics. This is a type of analytics where the algorithm learn from labeled training data to make predictions or decisions. Now, the connection it has with predictive analytics is that it helps predicting the classification or value of a new database on its proximity to existing data.
Okay, so going back to the topic, it makes one curious with how Kanir's neighbor even came to exist in the first place, which is why I searched up some videos on its history, and this is what I found. So the first point in the Kanir's neighbor timeline is the collaboration at Berkeley during 1951, when Evelyn Fix and Joseph Lawson Hodges Jr. joined forces in starting the long history of KNN. Additionally, the collaboration resulted in an unpublished report that introduced a non-parametric classification method. And last but certainly not the least, the KNN's precision and efficiency have continued to improve throughout the years after Cover and Hart's contributions, becoming a more reliable, simple, and effective tool for individuals to use in the academia and industry setting.
Oh, we have an insightful comment from Binary Bird 1050. He is right. There are two types of uses for k-nearest neighbor, classification and regression, where the classification problem acts like a majority voting and the regression problem takes the average of the given values and predicts the possible outcome. It is to be noted that the difference between the two is that classification is used for more obvious graph, while regression is used for elements close to each other or continuous.
As an example to our classification, it is like teaching a child to identify a pig based on showing several different pictures of a pig and other animals such as a cat, a dog, and etc. When a picture of a pig is shown, we say pig. If it's not a pig, we say not pig. After doing it several times with a child, we can now show them a picture and the child will know correctly if it is a pig or not based on similar criteria that he has noticed.
Then we have our regression in Python, which is like having a helpful friend, K, who predicts a numerical value based on the values of its nearest neighbors. Suppose you have known temperatures for certain days and want to predict the temperature for a new day. You create a KNN regressor introducing K to the concept of nearby temperatures by training it with known temperature day pairs. When you encounter a new day without a known temperature, you ask K to predict it by considering the temperatures of the closest days.
Nice question, Anita Huxley. How does K nearest neighbor work exactly? So Sir Delos actually replied to this comment by saying that the general idea of conducting K nearest neighbor has 5 steps. You select the value of k, you calculate the Euclidean distance, you take the k nearest neighbor according to the calculated distance, you count the number of data points, and then you assign the new data points to the category. Hi guys, so this is going to be a brief demonstration of how we are going to code k nearest neighbor in VS Code. So for example, we will classify a new point if it's green or white. So first and foremost, we must start by importing the necessary libraries. So right here, I imported matplotlib and numpy. Matplotlib is for our plotting systems and numpy is for our mathematical equations. Now from collections, I also imported counter, which is something we're going to use at the latter part of the code. So after importing all our needed libraries, we're going to make a dictionary. So this dictionary is going to contain our points, which is green and white, colors of LaSalle. Now, as you can see here, there are values. You may ask what these values are. So let's imagine we are plotting on an x and y axis. The values that I am highlighting right now are the coordinates that correlates to color green. And the values that I'm highlighting right now are the coordinates that correlates to color white. So that is what it means. Next, we are going to create a new variable. So this is going to, we created this for the machine to predict if it's going to be green or white. Now that we have established our points and our new point, we are going to teach the machine how to predict. So let us write an actual code that would perform the k nearest neighbor. So first we do class KNN. So what does this mean? This just means that class, we're going to create an object in Python, which we're going to call KNN, short for k nearest neighbor. Under there, we are going to define init self k equals c. So what does this mean? We are going to define, which is we are going to have one characteristics of KNN to be itself of the k value. Okay, now what does init means? This means that this is going to be the first thing that our KNN, that our object would recognize once the code starts running. So the first thing it's going to recognize that is that the k value is number 3. So under here, I'm just going to type self.k equals k. It's just a variable. Okay. Under here, we have def, fit, self, and points. Now, what does this mean? Fit means that we are telling the AI which model they should follow. Okay, so this is a little confusing, so I'm going to try to explain this in a much understandable scenario. So imagine we are in a class and I am the teacher and I need some qualities of a good student. Now let's say that the qualities of the good student is based on Sir Delioso. By using fit, I am telling the class that our rubrics for a model student would be based on Sir. So in code, we are telling the machine that in order to determine the new point, we would base or we would model it on the points or the pre-existing points that we have written up here. So under here, I'm just going to type another variable. And next, we are going to define our Euclidean distance. So basically, our Euclidean distance is just the shortest distance from 2 points. This is very important in our code because in KNN, we are finding the nearest neighbor. So we are finding the nearest points around the new point. So under here, I'm just going to write my code for my equation for for the Euclidean distance. So this is where our numpy comes in because they are able to arrange the numbers without actually manually typing it. So Here we go. So this is the what do you call this? The equation. Next, we are going to predict. Now, what does this mean? So one of the characteristics of KNN is they're going to predict the new point. So predict self distance. New point. And then under here it would be the distance. Why distance? Because we're going to find the distance of the new points, and we're going to find the distance of the new points and the pre-existing point. So that's why it's distance under here. And inside the distance list, we're going to have nothing in it. There's nothing inside the list. Why? This is because the distance from the new point is going to be determined after the code starts running. So if I already have a distance right here, the code is not going to work and it's going to have an error. And then now moving on, we would create a nested loop to calculate the distance of the points. So let's do a nested loop. So this is a for loop. So the distance is equals to the Euclidean distance, which is the point and the new points. So the Euclidean distance of the points and the new point. And then after finding the distance, we're going to append it on our empty list of distances. So distance and category. So this is our loop. Now we have to exit the loop, and we are going to categorize our new point that would see if it would be categorized in green or in white. So let me write the code for this. So categories. And then under here we have the result. So the result we're going to have a counter. So the counter class is to count the occurrence of each categories in the categories list. So there we're going to write a most common part which returns a list of tuples where the first element is the most common category and the second element is count. So we then select the category itself and then assign it a variable result. So I'm going to type the code categories most common. Here we go, and then return result. Lastly, so this is our object, so this is our k nearest neighbor, and now we are going to see and put our code into use if it would work. So in order to do that, we are going to create a new variable, and then we are going to write KNN. So it means that this variable would use the KNN object. And then we don't forget to put the k value. And then under here, our variable would be modeled after the points. Oh. And then lastly, we are going to print it out. So bgdt, we are going to predict, because we're going to predict the new value. And I believe that this is going to print out the prediction if it's green or if it's white. So let's see if my code works. And I have an error. Okay, let me check. Here. I'm sorry, I wrote append. Okay. Check again. Oh, there's error talaga. So I found my mistake, which is the points. I wrote point, and there should be an S here. So now I believe the code runs, and our new point is green. So our new point, which is 4, 1, is green. So now let's change it up and see how our KNN would predict. So let's pretend it's 5 and 6. And boom, it is now white. So feel free to ask any questions if you have any confusion regarding the topic. If not, thank you very much and good luck on your activities.